wait, you can have her.
Okay, so we've got the triangle here, ABC. We've marked off that AB is congruent to BC. So that's our given. The goal is to get these two guys down here congruent to each other. Now the trick to this proof, and if I were to give this on a quiz, I would not give you this little. I'd give you 2 more hints to play with. I would also add in that line right there. So I'd be working with 2 triangles. Because this whole chapter has been about working with pairs of triangles. And I would tell you that those pieces are congruent. Should we what? Yeah. I'd add that in. So over here are my 2-column proof. Let me get my givens written down so we're sure what we've got, and then we'll see if we can't get to this objective. So my initial given was that AB is congruent to BC. Given. I'm also going to give you that D is the midpoint of AC. Given. Now that one in red, theoretically that could have been added up here. So now the real objective is, can you get from these 2 facts to the idea that A is congruent to C? Or to take it back a step, can you get me to saying that these 2 triangles are congruent? This phase, yeah.
You could do AD is congruent to DC.
Okay. AD is congruent to DC. Why?
The definition of midpoint.
Definition of midpoint.
Should you add in that
BD equals DB? I mean, this guy here equals itself? Yeah. Why? Yeah, the reflexive property says this guy's congruent to itself. That's a third side, isn't it? Do I have enough to say I've got congruent triangles? I've got 2 congruent triangles now because I've got enough tidbits between them, so I can say triangle ABD is congruent to triangle CBD. Side, side, side. Let me pause there. Are we okay with that much? We've been practicing that a lot the last couple weeks. This is the bulk of the test, is on getting from here to here, or at least filling that guy in given this. And now the last thing I can say is, well, if these 2 triangles, this triangle here and this triangle here, are congruent to each other, that must mean that every corresponding pairing between them has to be congruent. So angle A is congruent to angle C. So these guys are corresponding parts of congruent triangles and are therefore congruent.
Wait. You lost me.
Okay. Once I say that these 2 triangles are congruent, so that's these 2, that means that everything on them that corresponds also has to be congruent. So the definition of congruent triangle or congruent figure is that all measurements are the same between the 2 figures. So that means that if these 2 triangles are congruent, that these angles have to be, because they're parts of those congruent triangles. And that's what CPCTC represents. The idea that once I've said 2 triangles are congruent, which I did there, I can take any 2 corresponding parts and say they're congruent. And that is, I believe, what I set out to prove, isn't it?